In this tutorial, we will look at the vegetation tools in the RhinoLands interface. These tools are located in the Vegetation and Hardscape tab. Lands has a plant database that allows us to insert any of the available species, as well as consult botanical data about the species. At the top, we find a search box that allows filtering species by their name. When typing in this box, the plants whose common name contains the entered text are displayed. The rest is divided into 3 areas. The first area is the filter zone, where we filter the species with the search criteria we specify. To filter, we can use the drop-downs to choose different morphological characteristics, such as plant type, leaf type, or flower color. Or filter by activating the checkboxes to select additional characteristics, such as whether the species is fragrant or suitable for narrow streets. It is also possible to filter according to the type of soil suitable for each plant. This area also includes an interactive map that shows the climate zones by color. We can select a region on the map or use the temperature checkboxes to limit the list to those species that tolerate the specified climatic conditions. Next, we find the plant species list, which shows us the species that match the search criteria. As you can see, as we apply filters, we notice that the total number of species found at the top decreases. The list is sorted alphabetically based on their name. By clicking on the corresponding title of each column, we can sort it based on this characteristic, or even by numerical value, if applicable. On the right side, we see the images of the species and a representation for each of the display modes that we will see later. With the Clear button, we deactivate all applied filters, and both the map area and the filters or images can be hidden using these arrows. If we select each of these species and click on Properties, we access all their information. If we want to edit or supplement their data, we must first activate the checkbox at the top. All the information contained in the species is distributed across these 5 tabs. The first one contains the origin and climatological information of the species. The Morphology tab, the Characteristics tab, which gathers the filters applied to this species. And in the Display tab, we assign a representation model for the species in the 2D, conceptual, and detailed display modes. By clicking on Assign, we can choose a different representation from the existing options. For the 2D tree crowns, as you can see, the path to the team where these representations are located is visible. So you can additionally create custom crowns and add them to the same folder to assign them to a species in the same way. If a crown is saved directly with the same species name, the assignment will be automatic for this species. If we select and accept, all the modifications we make will be saved for all future files and projects. When we see representations in gray, they are assignments that are not specific to this species, but rather automatic or default assignments, as is the case with the conceptual representation, where, being a conifer, this representation is assigned. And the same happens with the detailed one. The Render tab works in the same way. Here we select the model that we see in the rendered mode or in the final render. If we click on Assign, we see all the available render models. Most of these files are in ARTRI format, which is the resulting extension from AccuRender Plant Editor. If we click on the Plant Editor, the first time it will give us access to download and install this editor. Once installed, clicking on this button will open the Plant Editor. In this editor, we can adjust the realistic representation of the plant, the height, the branch opening angle, or replace its textures. This way, you can change, for example, the flower color of a species and create new varieties. If you want to know more about AccuRender Plant Editor, there is a detailed video on the channel. For those species that are suitable for groundcovers or topiaries, we can also assign a representation of this type. When we accept the edits made, it will ask if we want to save and overwrite the changes made for this species. If we want to add a species that is not in the database, we have the option to create a new species, filling in all the fields, Or to make this process easier, we select a species with the most similar characteristics or representation. For example, to create a new variety of Abelia, I select the one that most resembles the one I want to create. We select the species and click on Copy. We give a name to the new species. I will name it Abelia paviflora. And we would review the information to ensure it is correctly documented. If we want to select a different representation, by clicking directly on a representation, it acts as a shortcut to edit the representation we click on. If what we want is to remove a species from the plant database, we have the option to delete and also the option to export the list data in CSV format. Using the heart-shaped buttons, we set our selection of favorite species. And from the drop-down, next to the search bar, we can filter the species we have marked as our favorites. Also filter by customized species, which are those where we have edited some aspect, filter by newly created species, or by those that have their own realistic representation or a representation suitable for a vertical garden. Now that we know the plant database, let's look at different ways to insert these plants into our projects. With the Insert Plant command, we insert a specimen of the selected species wherever we click. In the different vegetation commands, this tab will appear in the insertion dialog. In the tab, we need to select which plant from the database we want to insert into the document. To select it, we click on the button, Browse, and using the database we have seen, we choose a species. We select that species and click on Select. With this species loaded, the next step is to adjust its size. The diameter and height values are related, so if we use the DAT slider, we increase or decrease both values at the same time until we get the approximate dimensions for the species. With the Natural Variation checkbox, we give a range of variation in size so that when inserting consecutive plants of this species, they have a size variation among them. And they don't all look the same, but appear more realistic. We can also control the rotation and the option to merge the outlines of the tree crowns in the 2D representation. We accept and click with the left mouse button on the points where we want to insert this plant. As long as we don't finish the command with Enter or the right mouse button, we continue inserting specimens. Between insertions, we can modify some of the plant insertion parameters using the editing panel. Other ways we can insert plants individually is by painting plants. The plants that have already been used in the document are listed in this box. We can select the plant we have used previously or load a new species from the database. With this method, we make a first click with the cursor, and until we make a second click or finish the command, plants will be inserted in a triangular matrix along the path where we move the cursor. With this command, we can also choose the delete option from the command bar to reverse and remove the specimens. Along the path where we move the cursor again. Once finished, we can also select these plants one by one to move, delete, or adjust some of their parameters. With Plant from Points, we place a selected plant wherever there is a point in the drawing. If it generates a couple of points, or it could also be a point cloud. This command does not allow indicating points in the drawing. Instead, we have to select already existing points. And each selected point will define the insertion point of a specimen of this plant. The Plant from Block tool does the same, but instead of points, it replaces all instances of a block with a specimen of the plant. This is useful for cases where we might start from an imported document that indicates the distribution of the plants, using a simpler reference or block, and now we want to replace it with a realistic plant of its species. I am going to define a new block from this box, which I rename as Plant Reference. From the Block Manager, we can view all the blocks in the document. This entire list corresponds to the different representations of lands objects that we have already inserted, such as urban furniture pieces or the plants themselves. And now we have added this new one. Even if we delete the instances of a block in the drawing, the definition of this block remains saved, so we can reinsert instances of this block without needing to create it again. To remove it completely, we have to do it from the block manager. When inserting the plant from blocks, the first thing is to decide if we want to replace it. If we want to remove the block instances, we leave it as yes and select the block. Now, in all the places where there is an instance of the selected block, it is replaced by a specimen of the species. In addition to inserting independent plants, the Plant Row tool distributes plants along a path curve. I'm going to load a different species this time, and with this command, the Row tab is added. In this tab, we can adjust the plant density along the path. It can be by units or by spacing between them. We choose one of the options from the command bar and draw the path. Once created, we can modify the position of the control points or edit the row parameters, such as the number of units, the distance of the plants from the origin curve, and also the possibility of combining more than one species. If we set the number of elements to 2, under the row selection, the species is duplicated. By selecting one of them, I can replace it with a species already used or search for a new one from the database. And, in this way, achieve rows that combine species. And we can arrange these rows with different distributions. Before continuing with the rest of the commands, let's look at the different representations for the plants. I will return to the rendered mode, and if we go to the options in the editing panel without having any elements selected, we have full representation modes for 3D plants. With the realistic mode, we visualize the 3D model in the way that most closely resembles the plant, which we will see in the final render. If we activate this mode, we can use the 3D of the species or a billboard. Billboards replace the 3D with an image of the species that will automatically orient itself to our point of view. If we set the view to shaded, we see that it is a plane instead of the entirety of the meshes that make up the 3D. This option is advisable to use for large projects where we are interested in obtaining the best possible performance, as this change will have no effect on the render. We also have the option to use detailed 3D, which is a representative block that is not as true to the species. We also have the conceptual mode, which sets a block based on the type of plant and its shape. And finally, the elevations, which is a 2D drawing of the elevation based on the type of plant, which will also orient to our point of view. If I position myself in the plan view, which I have set in 2D mode, we see the plants represented by the 2D crown, assigned to the species. We have the option to keep the color shading on or off, or instead of these, use the layout plan symbols, which modify the tree canopies to a simpler 2D form, such as a circular shape. As we insert different plants, they will be listed in the selection list of the editing panel. If we select a species from the drawing, in the editing panel, we configure the parameters for this single specimen. Whereas if we select the species from the list or through the drop-down Edit Species, we access the modification of parameters that are common to all specimens of the species. We can modify the name of the species, the initials associated with it, or change the maximum height and diameter it allows. To change any of the species representations, we click on the Change button and select a different one. Unlike the edits we make from the plant database, the parameters we edit from this panel only apply to this file. They will not be saved for future projects. At the bottom of this tab, using the slider, we define the detail of the plants in realistic mode in the graphic window. Even if it's at a lower level, when we render, the level of detail is set to maximum by default. For this reason, it is not advised to increase the level of detail during the work process if we want to achieve the best performance from the program. In the case that we have the shadow of the tree crowns activated, from this button I can deactivate the shading only for the species I am editing, but not for the rest. For 2D representations, and also elevations, the color that the species takes for the contour lines is taken by layer. In this case, it is taking it from the plantation layer. By modifying the color of the layer, the contour color for all the species contained in this layer is modified. To give different contour colors to different species, from the General tab, we can select a different color than the layer for each species. That color will be applied to both the tree crowns and the layout symbols. If we return to the document properties and a realistic 3D view, in the Document tab, we set the seasonality. Depending on which season of the year we position ourselves in, the realistic model adopts one appearance or another according to it. All the plants in the document adjust to the season selected in this tab, but by selecting a species, with the lower checkbox, we can indicate that this plant maintains the appearance of a different season, both in the viewer and in the render. And finally, in the Document tab, we choose the quality with which to render the plants. We choose between viewer quality, good quality, or final quality for an optimal result. Continuing with the rest of the vegetation tools, the Forest tool organizes the elements within a bounding curve. We choose one of the species from the database, and in forests, it is advisable to deactivate the merging of the tree crowns, so they are not recalculated. While we are working and once we have finished the forest and do not plan to edit it, we can activate it again. We select a closed contour that we have previously defined or create a new one using one of the options in the command bar. In the Forest tab, we control the density and distribution of the plants within it. The forest can be distributed in a random arrangement where we define how many units it consists of and what the minimum distance should be between the plants. If both parameters cannot be met in the space we have delimited, the value of the indicated minimum distance prevails. Therefore, at the bottom of the tab, it shows us the total number of units being inserted. In forests, we can create interior contours. Through the Forest drop-down, we click on Add Holes and select a contour that is within the forest boundary. In this way, the plants that are within this last contour will be removed. To remove them, we click on Remove Holes. We can reallocate the forest for an alternative random distribution. If we don't want a random arrangement, the plant species can also be distributed spaced in columns and rows. For this, we have different matrices. In spacing, we choose the shape of this distribution. If we choose square, the value we enter in this box defines the spacing between the plants on both axes, maintaining this square shape between them. With rectangular, the second box is enabled to enter a different distance on the x-axis and the y-axis. We have options for a triangular matrix, indicating a value in the rotation box. We rotate the forest, and with dispersion, the plants are shifted from the grid points of the matrix to give a more irregular and natural feel. Just like with the rows, we can also combine more than one species in the same forest by choosing from the selection area which species to combine. For the terrain, between the stairs, I will use a rectangular forest of the species Stralvia clevelandi. With walls so close, it is advisable to maintain a distance at the edge of the forest so that the plants do not protrude from the walls. I will arrange it in a triangular matrix and a random distribution, and combine the species. Some species have several realistic representations to choose from. In this case, depending on the flowering color, we choose one of them and accept. If you want to change the color or the representation of the crowns, remember, Select the species from the list. When we have no selection made, to access the representations of the species. When we consider the forest finished, we can then reactivate the merging of the tree canopies. With the vegetation, we can also copy the parameters from one element to another. For the second terrain, between the stairs, I only draw the outline with a rectangle. Now, by selecting the previous forest, we copy the properties to another selected curve. To make it look different from the previous forest, we rotate it 180 degrees. The Shrub tool allows us to create shrub masses. I am going to create 2 areas of low shrubs in these side areas. We search for the species and validate it. From the Shrub tab, we can configure the distribution per linear meter, per square meter, or in the matrix form, as we have seen for the forests. Depending on the chosen option, the corresponding density box is activated. If you choose Matrix, the Forest tab appears, which we are already familiar with. For the 2D representation of these shrub masses, a wavy outline is used, which we can fill with shading if we activate this box. By clicking on the image, we choose a shading pattern from the list. With the up and down arrows on the keyboard, we can switch from one to another. We also choose the color, size, and rotation of the selected shading. Once created, in 3D, each specimen is painted. In the 2D view, we see it represented in this other way. If we adjust this shrub by linear meter, it only follows the contour curve. I will copy the same shrub for the space on the other side. Ground covers are represented the same as shrubs in 2D. But we can only choose species that have a specific realistic representation for ground covers. They are configured by unit, square meter, and the scale of the plant. We choose a shading pattern different from the previous one for this species. And we select a contour curve. The size of the contour is scaled according to the scale of the plant. Finally, with the Topiary tool, we wrap any geometry to simulate a topiary art object. The available species are those that have a specific realistic representation for topiaries. These representations are the ones we found in the Render tab of the plant database. The settings are the same as for ground covers. But this time we can select any solid, surface, or mesh we want to cover, as is the case with this figure in the central part. If we hide the geometry now, we get a better appearance of topiary art. To achieve a denser effect, we play with the density and scale of this species. To clean the document of blocks and loaded species that are not being used, the list in the editing panel shows us the species that are not in use. By selecting them, we can purge them species by species or all at once. When we clean them, they will no longer appear saved in the plant insertion box. The plant elements also automatically adjust to the terrain. When we insert a species, we can enable or disable the terrain adjustment from the options in the editing panel, or change this setting once it has already been inserted. If we want a created or imported object to behave like a plant, we have the tool to mark the object as a plant. When we select the object, this dialog box will appear, allowing us to indicate which species we want to identify this object with. By doing this, this object will be counted as if it were a species in the plant list, listed in the project documentation, and it will also adjust to the terrain surface, if we indicate so. From here, you can finish designing the vegetation in our projects. And we'll see you in the next tutorial with the documentation tools.